We're here at the Sharp Microelectronics Technology Incorporated facility in Camas, Washington, just across the Columbia River from Portland, Oregon. The three-story, 102,000 square foot building, which opened in February 1990, is home to SMT and to Sharp Electronics Corporation, which provides sales and marketing support for the products manufactured and assembled by SMT. We're going to meet with Dan McGill, the manager of manufacturing at SMT. Dan will take us on a tour of the facility's liquid crystal display, flat panel display assembly operations. Our tour begins with the donning of special clothing, necessary, as Dan explains, in order to ensure the integrity of the product.
These gowns are specially cleaned each week and then sealed in plastic bags. The gown material itself has a carbon filament thread to it so that electrostatic does not build up. It discharges instead, so it's conductive.
Okay. Now, why am I wearing this? What's the purpose behind this?
Well, the area itself is in a class 10,000 clean room. So what we're trying to do is we're trying to minimize the amount of particulate contamination.
If you were not to do that, how might the contamination compromise the product? What would we see?
Well, some of the activities that we're going to do is very close tolerance work, and it also incorporates a vision system. So if we have a piece of lint or a bubble or something like that, we could not only have a conductive bridge or an electronic short, but also it interferes with the vision system to be able to do pattern recognition.
Okay. So it looks like the gown will keep fibers from my clothing or somewhere else on my body from compromising the room.
That's correct.
Then there's looks like a very attractive cap that you have
yes,
there for it.
There's also a bouffant, or a
Okay.
clean room cap that goes over all the hair, and since you have a beard, you'll have to have a beard cover as well.
All right.
So you'll have a beard cover and a mouth cover so that we can talk without any foreign matter falling onto the product or things like that.
So my mom was right. I probably should have shaved this thing a long time ago. Do people without beards have to wear the face mask also?
Yes, the face mask, but only those with beards, also the beard cover.
Oh, I see. Okay.
We have
and it
the
looks like I get a
beard
free
cover
shoe shine here too. Now, what's that all about? I've seen some of the employees come through.
We'll also have to change into our conductive shoes, because on the electrostatic protection, the floor is conductive, the shoes are conductive. We want to make sure when they come back from break, they can wear them inside the building, not outside. That they clean the soles of the shoes and everything, and
so it's a special shoe, or you
just a special cleaner, so that it cleans off the soles. So we make sure you have contact with the floor, and that any electrostatic buildup is dissipated through the floor.
Okay. And now, what are these here? I noticed some small finger
cuts. We have a lot of natural oils in our system, and anytime you're trying to make any bonding of two surfaces, you want it clean and kept clean. So these finger cots we wear over each of the fingers so that it protects the oil in the skin from getting on the product. And also there's a couple of cleaning agents that we use. And since we do a lot of high volume repetition movements, we don't want to make sure that you don't get any chemical chaffing or anything like that.
Now, why would you not wouldn't it be easier to just wear an entire glove?
Well, an entire glove gets awfully warm in its use. Plus, if you have it tight enough to where you have a feeling capability, it's then very restrictive on the circulation. First operation here is a glass inspection. This cell comes to us from our facility in Nara, in Japan, and it already has a liquid crystal material filled, but we want to make sure that it is very good in terms of quality, so we do an electrical inspection. This first inspection station here just lights it all up electrically so that you can take a look to make sure there's no line outages and no other problems internal to the glass cell itself, because remember, that's not a reworkable proposition. The other reason we do is we attach a barcode label so that this is the beginning of our statistical process control tracking process. Okay, what we have here, Dave, is we've put down the bonding tape, and the bonding tape holds the tabs down on a temporary basis until it can transfer onto the bonding head. The bonding tape, or sometimes called Z-axis tape, bonds with temperature, and it polymerizes to make the bond between the tab and the glass electrodes. You'll see in these tab placement machines here, there's a lot of mechanical devices, a lot of mechanical moving, and as the product goes from one stage of the operation to the next, the robotics move it along in its operation. At the beginning of each shift, the operators do a full calibration, if you will. They check the temperatures, the pressures, the bonding head, the timing, and all that information is recorded in a quality log at the beginning of the shift and at the end where the next shift starts. In addition to that, 1 out of every 25 units is removed from this operation here, taken over to the microscope, and under microscope inspected for bond quality.
So how many people does this particular part of the operation require?
Actually, 2 people generally roam back and forth between the 3 pieces of equipment.
Are all the people in the clean room trained for a specific task, or are they multitask oriented?
In our operation, one of the requirements is to be a multitask operation. You have to be able to do more jobs than one. And you have to be empowered to the point where you can recognize when something is not going right and take action to resolve that issue. So the training and the rotation scheme is worked out basically by the operators. They'll do a day rotation, or some of them will do a week rotation or whatever. But essentially within the bonding room, they are all trained on all operations.
So at the end of this particular station, the first station in the manufacturing process, at what point is the product?
The product at this point, once it goes through the three tab placement machines, is they now have a what they call a liquid crystal display filled glass sandwich, and on that sandwich is located the segment 1 and segment 2, or the segment drivers, and on the third machine the common drivers. So in essence, the drivers, or the integrated circuit chip, has been placed and bonded onto the electrodes in the glass on the full VGA configuration on this particular model, which is 640 by 480. Okay, Dave, this is a solder operation. What we're trying to do here is finish the electrical connection from the tabs to the printed wire boards. So the tabs have bundled the 640 by 480 through a integrated circuit, and it now comes out on the balance side, so we're essentially bundling 200 on one side, 200 electrodes, and comes out on 20 electrodes on the PWB side. This operation here is robot soldering, so we're going to solder the PWB to the back side of the tab. And to do that, the operator has already made an alignment, put it onto the robot, and the robot is a rotating fixture, so we load one fixture while the other one's being soldered. And then the operator finally takes a look at it to make sure the quality is acceptable on every product, because he's going to initial it with his name and then do a barcode read-in. So every product that goes through every robot has a recording on a traceability or an SPC document with the barcode system.
Now, it looks like the environment within which the actual soldering takes place is at least semi-enclosed. What's that all about?
Well, it's semi-enclosed because the solder itself is a lead-based solder, and we want to make sure that we're evacuating or exhausting all the solder smoke. So it's fairly of an enclosed system. The booth itself is exhausted. The robot is a auto feed. There's a spool on the top with solder that automatically feeds the prescribed rate. It's programmable logic controlled, and we're soldering in a slight flow of nitrogen or inert gas so that you get good bright tinning.
At the end of this process then, at what stage is the product?
Well, at this point it has the electronics on the sandwich device to be an operable device. What we need to do finally is tie it together with jumpers, because the the circuit boards are not quite tied together yet. So electrically we'll come over here to the final operation in the bonding room, and we'll do jumper lead soldering. Okay, this operation here is called jumper solder. And what she's doing is she's taking the pre-cut jumper wire and she's soldering between the two circuit boards on each of the corners so that they're all tied together electrically.
Now I have to ask, why is this a manual soldering process and the other a robotic process?
Well, this particular one, since the jumpers are very small and they're 28 leads on each side, and they're very, very careful to line up. Secondarily, it's actually on two different planes. The common PWB is on the back side of the glass while the segments are on the other side. So we have to have a flex circuitry and it's not on the same plane. Also, there's many operations that even mechanically cannot be done as quickly nor as accurately as with the operators.
So there's still very much a place for the human equation in the high technology
Yes, absolutely.
formula.
Absolutely.
I've noticed that the workers who are actually in contact with the product have a small connector on their wrists. What's that for, Dan?
Yeah, that's called a ground strap. As well as the conductive shoes, and the chairs are conductive because the floor is conductive, the work surfaces are conductive. That ground strap is also a protection because the ladies here are actually picking up the glass panel and coming in the proximity of the electrical components on it. And we don't want to produce any static shock to any of those components.
This kind of work obviously requires a great deal of focus and concentration and accuracy on the part of the workers. How do you deal with the boredom factor? How do you keep people stimulated while they're doing the work?
They schedule their own trade-offs where they can do other operations. To be trained on all operations, the objective is for a person to learn all jobs in all places. So variety helps somewhat. Now, they'll do a self-design or a work design on how frequently they'll trade off and what operations they'll trade with.
I see, so there's obviously a certain amount of participatory management going on here.
Yes. Also, a new concept we're working on in terms of ergonomics, since we do a lot of repetitive motions, we not only need to trade off positions, but trade off jobs so that we're using different muscle groups in those job trade-offs, so that some way we can relax whether you're doing a pinch movement or some other movement with your fingers.
To recap for us then, at the end of this station, at what point is the product?
At this point, the product is actually electrically operable. You can, if we were to connect a signal generator to it, it will generate a signal, it will write onto the display, and it has all the essential characteristics of a laptop computer, the display portion anyway. Okay, let's go over here to inspection 1. Okay, we've had a couple of preparatory steps in the meantime. We've had a bake cycle and an application of what we call seal glow, which is a humidity seal along some of the bonding surfaces that we've prepared. So essentially this is the first electrical inspection, inspection 1. And as you can see, we have an electrical fixture here that is what the industry calls a bed of nails in the back side. We're not actually using the cable connection yet, but a series of pins onto the back of the display itself make electrical connections. And as she slides the block in from the left and makes that connection, she'll then turn the unit on. And what she's essentially inspecting for here is a on or off condition. Any line outages, any obvious defects. But primarily electrical defect to make sure that we have successfully tied together all the electronics from the PWBs to the tabs to the electrodes. We've designed our process to be consistent with the ISO 9000 quality system that we'll talk about later. But our each shift has a process technician, and our maintenance people or process technicians are responsible for the equipment, the process, and the product procedures.
Dan, I noticed that there are a series of illustrations and even written instructions above each one of the workstations. Tell me about those.
These are called bench specs. What they are is they're a condensed version of the written process procedures. Procedures are developed from the product specification and the inspection standards, and then on a training. The operator is trained to the written procedures, and then a trained operator, once trained and certified, then refers to the bench specs in the general operations. We've now verified that the panel and all the electronics is operable on the unit. At the next station, what we want to do is we want to install the display into, in this case, the customer viewable cabinetry. Now the cabinet itself, the plastic cabinet, has been prepared in another operation, and it's brought forward into the line operation at this stage. So we're going to marry together the liquid crystal display glass sandwich and the plastic bezel. Now in doing this, the operators are going to, in this particular application, put the display into the plastic bezel, and then there's a metal bezel that goes over it, and the electric drivers then drive a locking screw, and that's all set on a certain torque setting and that sort of thing. Part of the operation here, as you can see, is they're removing the barcode that was on the glass itself and now putting it on the plastic. We do that because we have a little more room, and also we've mated this with a metal bezel, screws, and plastic, and that's going to apply a certain amount of torque. So we want to keep this match set in our data collection system together. This inspection station now is looking at not only the liquid crystal display cell, but also the metal bezel and the internal workings under torque from those set screws.
I'm sorry, what's that little high-tech hammer that I see in operation here?
Well, since we've put the whole unit now under stress, we want to be sure that we do some physical shocking. We'll also do this again at the last inspection to make sure that the stress hasn't adversely affected the display itself, and that there are no solder joints that are in contact but not solid. Oven number 10 heats the entire screen up to 60 degrees centigrade, and then as it comes out of oven 10 cycling, it's then tested hot at 60 degrees centigrade, and then force cooled and then tested again. A couple of primary reasons for that. One is, as you saw just before inspection 2, we put a metal bezel with a considerable number of screws into a plastic container, into a plastic bezel, and we put the whole system under some torque. We want to make sure that under heated condition that torque doesn't get any worse or exacerbate any of the difficulties with the inspection of physical fit or electrical connections. The secondary aspect for that is that there's a lot of solder joints. This is an electronic device, and we want to physically and thermally shock those solder joints to make sure that they're in good contact.
So how long does the unit stay in the oven?
It's approximately a 50-minute cycle. It's at 60 degrees for 20 minutes.
All right, so this is inspection station 3, Dan, and this is immediately after the oven, is that correct?
That's correct. The panels are taken out of the oven at 60 degrees centigrade, which is about 110 degrees Fahrenheit, and tested hot. Now, liquid crystal display material behaves a little differently at higher elevations or higher temperatures, so we want to make sure that we test it in all types of conditions. The other thing is the circuitry is all hot now, and we want to make sure that we light it up electrically to make sure that all those circuits are good bonding. Okay, Dave, now this is inspection 4, or final inspection if you will. We've tested it, we've heated it up, we've tested it hot, we've force cooled it, now we're going to test it again. Now 100% of all products go through this sequence of testing. So this test sequence here is again the same as inspection 2 and inspection 3 on inspection 4. The only difference is we take a current reading on the cold cathode fluorescent tube to make sure that it's within specifications before it goes out. Now again, you'll notice that we also use the physical hammer on it as well, because we have heated it up and we have cooled it, and now we want to physically shock it again. This is truly the end of the line here. What they're going to do now is they've cleaned it all up. We've put a new protective coating on it. We do the last visual inspection, make sure that there's no scratches on the bezels and that all the screws are there, that sort of thing, and that everything looks good. And now we need to take that working serial number, the barcode, read in from that, read the customer specific serial number, and then the badge number. That completes our traceability because each customer wants their serial number a little bit different. We've now registered it in the same database file as our working barcode that followed the operation from the very first glass inspection. A U.S.-based operations is critical in terms of material lead time. The cycle time for materials between here and Japan are 4 to 6 months in design and starting and stopping the pipeline once it gets full. With us located here on the West Coast, essentially it's half of that. It's about a 3-month type activity. And the more local sourcing that we can pick up on our components, the more leverage we have on flexibility for that pipeline.
How important is it to have customer access to the facility also?
In the 2 years we've been here, or about a year and a half of actual product output, it has obviously been very important because there certainly has been a lot of customer visits here. One of the requirements of many customers is a certification, a site certification when they begin a product development. So our customers come here when we first tool up to do the product and watch the operation and actually do a certification process. Different customers have different requirements, but they're physically on site here when we do the first product build. From the very beginning, when we started here at SMT, there was no room, there was no flooring, there was no ceiling, and since I had some experience with a quality system called ISO 9000, International Standards Organization Series Quality System, made the determination that that's how we were going to set up the line, design the line for compliance, and we began that operation. Some of our initial training, even in pre-employment training, was based upon satisfaction of some of the requirements on the ISO 9000 series. So we started with that premise in mind. We have just completed our mock audit at the end of March with our certifier agency, and we are planned or scheduled for the final audit for final certification in September. We did a sort of a partnership with Clark College, which is a junior college just down the road here, about 8 miles, the Washington State Employment Security, and ourselves, and we designed a screening process that screened applicants for manual dexterity, visual acuity, math skills, reading comprehension, and that sort of thing. And then we did an interviewing process here on site, and we selected people to enter into a pre-employment training program. So we designed some classwork that spent the first 5 days, the first week of class, in a business environment. They had to keep a timesheet, they had to return from breaks promptly, lunch was their own responsibility, start and stop times were closely monitored, and in the first week we spent a lot of time talking about their work environment. The other major thrust on that first week was communications. People were screened and hired specifically in mind that they must do multiple tasks. They must be able to learn more than one operation. They must be able to be empowered so that they can visually see when the product is working correctly or not. So for the first week, they did nothing but understood the environment. At the end of the first week, once they've been through their communications class, teamwork, team building, group dynamics, understanding their responsibility as a group member, then they made a commitment on whether they were going to continue with the program. We're now planning another 55,000 square feet. There's 108,000 square feet in this building here on 3 levels. We're planning the additional 55,000 square feet out in the back of the facility, and we're going to relocate the cafeteria and pick up some additional space for SEC and of course some additional space for liquid crystal display assembly. In terms of the total capability of the building site, there's about 200 acres here, so we could envision as many as 5,000 employees. Today we produce monochrome displays. In a couple of months we'll be producing duty color displays. That equipment is already on order and will be delivered. Not only the 1/480 but the 1/240, which is very tight requirement and restrictions on the electrode pairs. So capacity is not difficult to increase from a Sharp standpoint because we design and manufacture most of our own manufacturing equipment anyway. From the non-machinery is the labor. We have a training class understood, tested, and refined. We now are starting the building expansion. So generally we could do as many as 30,000 a month in our current facility, although it would be quite tight. But we are expanding, viewing the future at doubling that capacity capability up around 60,000 per month. The speed at which we grow, of course, is going to depend upon the market and the sales within the market. But many of the customers are already stating that they want their product produced here because of those reasons I mentioned earlier, in communications, the material pipeline size, and the flexibility.
So if I come back in about 18 months, will you give me another tour? I bet it would look measurably
You come back in
different.
18 months, you'll have to spend 2 days instead of 1, but we'll do another tour.
It would look a lot different, wouldn't it?
Yes, it will.
Great. Thanks, Dan, very much. We appreciate the tour.
Thank you.
Well, that completes our tour of the Sharp Microelectronics Technology Incorporated LCD flat panel display assembly operation. Sharp Electronics is the first Japanese high-technology company to invest in the United States with a liquid crystal display manufacturing facility, a facility designed to get closer to the end product's customer base. In addition to increased manufacturing capacity, the company's expansion plans call for the facility to serve as the North American factory service center for all Sharp LCD units built here and abroad. Our thanks to Dan McGill for the tour. Sharp's commitment to the Camas, Washington facility is obvious, so we look forward to a return visit in the near future as the facility and its capabilities continue to grow.